Okay, so moving on with our notes for 4.5 on max-min problems, we're going to look at number 4. We want to know which point on the curve of y equals the square root of x minus 2 plus 1 is closest to the point 4, 1. So again, we talked about if you hear the word maximum, minimum, smallest, largest, closest, that's kind of a clue that you want to be focusing on the vertex of your quadratics, that HK, that highest or lowest point on your quadratic. So we're given the graph of square root of x minus 2 plus 1, so let's sketch a little picture of that. We know our parent function is the square root of x. It's been shifted 2 units to the right and 1 unit up, so the point that was at 0, 0 has now shifted up here to 2, 1, and we want to know which point, and there's lots of points that could be on this graph, a ton of points that could be on this graph, which point is closest to the point 4, 1. So let me put 4, 1 right here. So closest, hopefully in your mind, you're thinking, okay, we need to do something with distance. If we want to know which point is closest, then we are talking about a length, a distance between 2 points. Well, recall when we were talking about graphs before, there's a zillion points that could be on the curve of y equals the square root of x minus 2 plus 1. There's a ton of x, y points, but instead of using x comma y, we said always, because x, y could be on any graph, we want to be a little more specific. So instead of x comma y, any point that's on the graph would be an x comma square root of x minus 2 plus 1. So that's how we would represent all points that are on that particular graph. They would have that general form. So if we want to know which point on that graph is closest, then we should be doing distance. And recall that distance is equal to the difference of our x's squared plus the difference of our 2 y's being squared. So we have 2 points here. We have this point right here and this point right here. And we want to know, we're trying to figure out the point, that closest distance, which point is closest to those two. So if we set up our distance equation, I know that distance is equal to the square root difference of our x's squared plus the difference of our y values. So the square root of x minus 2 plus 1 minus 1 quantity squared. And let's simplify that. Any chance we can simplify, we always want to simplify. So the x minus 4 quantity squared, I know I'm going to get an x squared minus 8x plus 16. I know our 1's here are going to nicely cancel, and a square root that's being squared, we're just going to get what's inside, which in this case is that x minus 2. And if we still continue to combine like terms, we're going to get this x squared, minus 7x plus 14. A much easier, nicer equation to be working with. So if we look inside that quadratic, our a term, if we're just focusing on the inside, is a positive 1, which we know if our a term is positive of the quadratic part of the equation, that means that our parabola would be opening upward and our vertex would be the lowest point. So to be talking about something that is a minimum, smallest, or in this case, closest, makes sense for this quadratic here that we have inside of that radical. And again, we want to be focusing on that vertex. Well, there's a lot of points that are on this graph. Again, keep in mind, every graph has a bunch of x, y points, but we weren't using x comma y. Instead of y, I changed y to d of x. And we know that our x is actually an x of the point on that graph. And our d of x is standing for a distance. So you plug in an x of the point, you're getting out a distance. Every time you plug in an x of the point, you're getting out a different distance. And HK is just another XY point that's on our graph. It just happens to be a special XY point because in this case, it's the lowest point for that quadratic. So if we want to know something about the point, then we want to be looking at H. If we want to know something about the distance, then we should be looking at K. And our question is asking which point. So that means that we need to solve for H. We need to solve for the x of the vertex. And we know that the x of the vertex is equal to the minus b over 2a, or in this particular case, our b is the negative 7, and our a is a positive 1, and we get 7/2. So the x of our point is 7/2, and keep in mind that we represented our point over, let me go over here, we represented our point over there. So if we take our 7/2 and we plug it into our point, we get the square root of 7/2 minus 2 plus 1, or 7/2 minus 4/2 is what, the square root of 3/2 plus 1, or if we want to rationalize our denominator, that would be, what, root 6 over 2 plus 1 for the corresponding y value. And so that is the point that is on that curve that is closest to the point 41. Now we could have found the distance. We weren't asked for the distance, but keep in mind, we could have solved for the distance, which means we would have had to look at K, which is the y of the vertex. And so if we had gone back to our equation, if we wanted to know what is the closest distance, then we could have taken that h value and gone to our distance equation and plugged in that 7/2, and then we could have solved for what that closest distance is, and that would have given us our answer. Okay? So I'm going to hold off on 5 so that you can do 5, and we're going to move on to number 6. So on 6, we are given that a baseball is thrown straight up, and its height in feet as a function of time in seconds is given by the equation h is equal to a negative 16t squared plus 32t, or I could have wrote h of t, because height is written in terms of time, equal to a negative 16t squared plus 32t. And we're trying to find the height of the ball when time is 1 and time is 3/2. So how high is the ball after 1 second has gone by, and how high is the ball when 3/2 seconds have gone by? So in other words, we want to solve for h of 1, which would be a negative 16, 1 squared plus 32 times 1, or a negative 16 plus 32, and h of 1 is equal to 16, or 16 feet. And when time is 1.5 seconds, or 3/2, if we solve for h of 3/2, we're going to get a negative 16 times 3/2 squared plus 32 times 3/2. Well, 32 times 3/2 is what? 2 goes into 32, 16. 16 times 3 is 48. 3/2 squared is 9/4. And times a negative 16 is a negative 36. And a negative 36 plus 48 is equal to 12. So we get 12 feet after 1.5 seconds. If we're trying to find the maximum height of the ball, so again, maximum, minimum, largest, smallest, we want to be thinking of the vertex. And it should make sense that they're asking for a max because our a term is negative. And if our a term is negative, we know that our parabola is going down and our vertex is going to be the highest point. So it should make sense that we are looking for a max. And that max on our equation our points are we're plugging in t's, we're getting out h of t's, we're getting out heights. And hk is just a special xy point. So if we want to know the max height, then we should be looking at k. If we want to know the time, then we should be looking at h. And we actually want to know both. We're trying to figure out the max height and the time at which that height is reached. So let's first solve for time. Whoops, sorry about that. Let's first solve for time, and we know that time is the x of our vertex, and the x of our vertex is the minus b over 2a, which is our b. Let me come bring our equation back here. Our b is that 32, and our a is the negative 16, and a negative 32 over negative 32 is a positive 1. So at 1 second is the x of our vertex. And to figure out the max height, if we go to our equation and we plug in that 1 second, then we will get its corresponding y value, which we know is going to be the max height. So h of 1 is that negative 16, 1 squared plus 32 times 1, which we actually had already solved up here, and we got the 16 feet. On part C, at what time, so we're solving for time, does the ball reach a height of 7 feet? So we're given that height is 7, and so if we set our equation, 7 is equal to a negative 16t squared plus 32t. It's quadratic. We want to make sure that quadratic is equal to 0. So I am going to actually do 0 is equal to a negative 16t squared plus 32t minus 7. And I prefer my first term positive, so I'm going to divide out a negative, making that a positive 16t squared minus 32t plus 7. Solve for quadratic. Quadratic formula always works, but I think this will actually factor. So 16 is a 4 and a 4. Our signs need to be the same, both negative, and if we use a 7 and a 1, negative 28 and a negative 4 will give us our negative 32. So it does factor. And using our zero product property, we're going to get t equal to 7/4 and t equal to 1/4. And it should hopefully make sense that you got 2 times, because our parabola, we said, is going down because a is negative. Our vertex, that point was 1,16. That was the highest point on our graph. And we want to know when the height was 7 feet. Well, we got 2 times. We got 1 time, which was 1/4 and 7. And then we got another time of 7/4 and 7, which means that the baseball hit a height of 7 feet on its way up after 1/4 of a second. And then it hit its maximum, and then it came back down and hit 7 feet again after 7/4 of a second, or 1 3/4 seconds. So I'm going to stop there and let you go back and redo number 5.